part 2 video of applications of dimensional analysis. In the last video we have already discussed the deducing an expression for physical quantities using dimensional analysis. So today also we can continue with the same. So today we are going to discuss a new example, that is very important example and which has asked in a previous question paper. So can we move to the question? So we can consider another example. The example is the velocity v of sound in a medium depends on the density rho of the medium and its modulus of elasticity E. Using the method of dimensions, derive the expression for the velocity of sound. And also it is given that take k is equal to 1. That is the constant. So here what we have to find? The velocity v of the sound. So that expression for finding the velocity v of sound we have to find. And the quantities depending on the velocity of sound is density rho and modulus of elasticity E. Okay, so how we can apply the method of dimension for finding the expression? First of all, we can write down that v is equal to, that is velocity equal to k into rho raised to a e raised to b, because a and b are the unknown dimensions, right? And now we have to find the dimension of rho. Rho is the density and E modulus of elasticity. Here V velocity. So all these three dimensions we have to find. So it is given here. What is the dimension of velocity? It is, yes, displacement by time, right? So how we can write? That is m0 L t raised to minus 1. And what about rho? Density. What is the equation for finding density? Density is equal to mass by volume, isn't it? So how we can write? M by volume is L cube. So M by L cube. So that will be M1 L raised to minus 3 T0. Then the last quantity is modulus of elasticity. How we can find the modulus of elasticity? That is stress by strain. So that stress we have already studied. Right, what is stress? That is force by area. And what about strain? Strain has no dimension, right? So that only the stress we have to find, that is force by area. That will be mass into acceleration force. That will be m L t raised to minus 2 divided by L square. So we will get it as m L raised to minus 1 t raised to minus 2. Okay. So now we can apply the dimensions. That is, here instead of v, we can apply the dimension of velocity. That is m0 L t raised to minus 1. And k has no dimensions. Right. So we can write the dimension of density. What is the dimension of density? Yes, that is m1 L raised to minus 3 t0 whole raised to a. Then E has the dimension of m1 L raised to minus 1 t raised to minus 2 whole raised to b. So that we are getting an equation. Now can we equate the dimensions on both sides? So first of all we can write it together. Right, after that we can equate. So what we will get here? Only one term is there. So like that we can write here. And in RHS we have two terms. So what about the dimension of m? Here we have m raised to a. And here m raised to b. So what will be the total? Yes, that will be m raised to a plus b. And what about the power of L? L has minus 3a here and here minus b. So the total will be L raised to minus 3a minus b. Okay. Then the powers of t. T here there is 0. So nothing will come from this side. And what about the last t? T raised to minus 2b. So that we can write down. So the equation will be m0 L t raised to minus 1. That is equal to m raised to a plus b into L minus 3a minus b t raised to minus 2b. Okay. Now what we can do? The next step. Yes, here we can equate the powers. That means we can apply the homogeneity principle. So the powers will be the same for each quantities, right? So when we are equating the powers of m, what we will get? Yes, that is a plus b equal to 0. And what about the powers of L? Yes, that is minus 3a minus b, that is equal to 1. Right. Then what about t? Minus 2b is equal to minus 1. Now we have these three equations, and from this we have to find the values of a and b. Okay. So how we will get the values? Here we have a plus b equal to 0, and b we can find from here, right? Minus 2b is equal to minus 1. Therefore b will be equal to 1 by 2. Isn't it? So that we have a plus b equal to 0 means a plus half is equal to 0. So what about a? A will be equal to minus half. So we are getting the values of a and b. Now what we can do? We can substitute the values of a and b in first equation. Yes, that is b is equal to k into rho raised to minus half e raised to half. Okay, that we can just rearrange this, because rho raised to minus half is root of 1 by rho, isn't it? Then what about e raised to half? That is root e. Then how we can write it together? V is equal to root of e by rho. So that is the expression for finding the velocity of sound in a medium. So that I will just remind it. That means here we have to find the velocity of sound in medium. That means V depends on modulus of elasticity E and density rho. So we can write it as V is equal to k into rho raised to a e raised to b. Now we can find the dimensions of velocity, density and modulus of elasticity. So what we will get? V is equal to m0 L t raised to minus 1, then rho, that is m1 L raised to minus 3 t0, then E m1 L raised to minus 1 t raised to minus 2, rho raised to b is here. Now we have to write the dimensions of each terms together. So m raised to a plus b, L raised to minus 3a minus b, t raised to minus 2b we are getting. Now we can equate the dimensions on both sides. Therefore a plus b will be equal to 0, minus 3a minus b will be equal to 1, then minus 2b is equal to minus 1. So that minus 2b equal to minus 1 means b will be equal to 1 by 2. So a plus b equal to 0 here. So a equal to minus 1 by 2. Now we are substituting the values of a and b in first equation. That is b equal to k into rho raised to minus half e raised to half. So that will be equal to root of e by rho. So that is the expression for finding velocity of sound. Is it clear? So today we can conclude. See you in the next video. Today we are going to conclude the video. If you like my video, please like, share and subscribe. Thanks for watching.